Welcome back, friends. We are back with the Algorithms and Olympia track at YByte. In this set of videos, we are going to look at this very interesting technique called the two pointers technique, which is basically going to give us algorithms that are more efficient than what would be the naive method. So let's just recap what we have learned so far. Well, we have learned that look, naive algorithms are a good starting point, but they can be inefficient. And thinking cleverly can bring efficiency. We'll see this again today. Efficiency is measured in the notion of complexity as to how many operations are required to complete the task at hand, and how does this number scale as the size of the input becomes large. Now remember, we do not want our algorithm to be doing more work than what is needed, and hence this notion of complexity is kind of our guiding light. We know that structure in the data, for example sortedness, can be exploited to gain efficiency. We have already seen this in binary search. When the list is sorted, then we can search using binary search, whose complexity is given by log of n, which is much lesser than, let's say, a linear search. Now in this set of videos, we are going to look at what is called a two-pointer technique. This is a very interesting technique. It helps us to solve what I call the expanded search problems, where our search goal relates to not just one item, but maybe, let's say, a pair of items together. So for example, previously we looked at a question that does a list contain, for example, a certain value. Now let's say we have a slightly bigger question and we ask ourselves a question like, look, this is a list available. Is there or are there any two items in this list which add up to a certain target? You notice that the search is no longer so straightforward that I can just look at every item. In fact, I should look at pairs of items and figure out if any pair adds up to a certain target. Now, this is what I call an expanded search problem. And as we'll see, under certain conditions, two-pointer technique will give us a really efficient way to solve this. And then we'll go and look at two more problems, where two-pointer technique is quite interesting and basically helps us to improve efficiency. So very, let's say, interesting trick, very interesting technique, and we'll learn this with three examples. The learning objectives on this lesson, well, we will learn about the two-pointer technique. We'll see what kind of problems are solved using this. And we'll also introduce the notion of quadratic complexity. Quadratic basically means squaring. So what we are looking at is algorithms naively that scale as, let's say, n square. So we will start with, in all the problems, we'll start with the naive algorithm, which we'll see scales as n square. And then we'll see how two-pointer technique brings complexity down, in fact, to a linear scaling. So it's very interesting. When we had a linear scaling, for example, linear search, we wanted to look for efficient algorithms like binary search, which went to log of n. Now here we are dealing with problems which, because of the pairing nature, have a quadratic or n square complexity. Hence, we are trying to go down to a linear complexity, and we'll talk about this in detail as we go forward. So in the next few videos, we'll look at three interesting problems which will illustrate the two-pointer technique. As always, we'll go through this in a very step-by-step manner, highlighting all the important points and developing the code slowly and systematically. If you haven't yet done so, please look at our website www.ybyte.in, because we have lots and lots of materials through which you can learn Python, algorithms, and programming in a fun manner. Take care. Thank you so much. Bye bye.